Okay, so today we are going to look at the sine, the cosine, and the tangent curves as functions and what's going on with that. So there's a few things. We're going to look at how it's related to um, our unit circle. All right, so we'll be thinking about all the key points around it. So let's take a look at this real quick. So as if we look at the sine curve, take a look as we go along the unit circle. Watch the curve. So you can see as it's going around, the unit circle from 0 all the way around to 2 pi. This is the sine curve. As it's going around, now it's going to come back the other way. You can kind of see a relationship here. You can keep spinning this if you wanted to in either direction, and it goes up, reaches the highest value of 1, crosses at 0, and you can see that those are the things that we did in class, right? You can clearly see that. So that's the idea of that. If you look at the other location here, let's look at this one. This one, I believe, is the cosine. And it does the same thing. As you go around the circle, as you go around the circle, it constantly hits those spots. It doesn't go above 1 and it doesn't go below -1, but it just keeps spinning and spinning and spinning. So that's the idea behind the sine function. A couple things you want to talk about is you have you both sine and cosine have some unique relationships. We're going to talk about the period, and now the period is pretty much how long it takes for the curve to repeat its graph. So in this case, you can see that the graph, it looks like it's it looks to be, since it starts at 0, 0, the first point on here is right here. This is the first point. You can see that this goes up, boom, it stops right there. That starts at 0 and ends at 2 pi. That means that the period is 2 pi. Now, if you were to graph it normally on like decimals or something, it would look like 6, but that means from 0 to 2 pi, and then the next chunk, this guy right here, it repeats itself. And if you go in the negative, it does it as well. You can see how it repeats itself, right? Makes sense? Now the domain, you can see the domain is the input, and that tells you how far the x and y axis. So the domain, we tend to write as negative infinity to infinity. That means the same thing as all real numbers. Now the range, what is the range? Well, the range, the highest it goes, looks like is here, and the lowest it goes is like right here. So the range is from -1 to 1. You can write it like that, or you could write it like this. -1 is less than or equal to y, is less than or equal to 1. Either one of those will work. This one on the left here, this guy right here, that is interval notation, and we like that. Now when we talk about function type, there are two types of functions. You either have odd functions or you have even functions. Odd functions have rotational symmetry, and even functions have reflection symmetry. So this is the sine curve. This is actually an odd type function, if that makes sense. All right, so that's the sine. So this is actually a function. This is f of x equals the sine of x. And we've seen it a little bit this last week. All right, let's see, moving on to the cosine. The cosine, you can see here, I know it's the cosine because it looks like the W, but it starts here and it ends here. This little bit right here, it looks like this also has a period of 2 pi. If you look at its domain is the same as the sine, and it should be because you told me it goes from negative infinity to infinity. And the range is -1 to 1. And these are all the same thing because you told me in class that it was just a translation of of sine. And the function type, you can clearly see it. I can fold it along here. And if this guy went over to the other side, so this is an even. It has reflection symmetry. Make sense? Awesome. So if you look at this, there's a couple of things you want to be mindful of. So if you look at this, it says if b is greater than 0, then the graph of either sine b of t or cosine b of t makes b complete cycles between 0 and 2 pi, and each function has a period of 2 pi over b. What does this mean? Well, in the activities that you did, you were dealing with some sort of sine, and you put some number in front of x, and that some number in front of x, we'll call it b. As some number in front of x, we'll call it b. That actually affects your period. All right, the period is 2 pi divided by b. So when we graphed y equals the sine of x in that one activity, you had a period of 2 pi. When you had y equals the sine of 2x, you had a period of pi. It was real tight. And then when you did 1/2, you got a period of 4 pi. So this is kind of crazy, right? So when you look at this, this is the cosine. So I want to know what the period of cosine of 5t is. Well, b is 5. So my period is 2 pi divided by 5. What does that mean? That means every increment of 2 pi over 5, it is going to repeat itself. So how do I know that that's going to work? I'll show you what I do. So I'm going to go ahead and I'm going to open up Desmos here. And if I type in y equals cosine 5x, and I hit this little guy right here and I change it to it's in radians. If you look, I'm going to go from 0 to 2 pi over 5. And you can see as I zoom in and out, here is my one complete, so you can see the one complete cycle of pi, or one complete cycle of the cosine. If I go back and go from 0 to 2 pi, you can see it happens, it goes through its cycle a couple times. So the period, if you go from 2 pi over 5, it does one thing. It slows it down a little bit, right? Looking at the next one, sine of t over 3. Well, this b, in this case, b is 1/3. So what I'm going to do is do 2 pi over 1/3, and that's a keep change flip. So keep 2 pi, change this to multiplication, flip it, 3 over 1. Now my period is 6 pi. What does that mean? It would, if I punch in sine of x over 3, it's going to take all the way up to 6 pi to get there. So if I type in sine of x over 3, and I change this to the regular old 0 to 2 pi, whoop, got the wrong function in there. X over 3 there it is. So here is 2 pi, that 6 is 2 pi, and we have to go to 6 pi. So if I change this to 6 pi, we set our And you can see there's the one complete cycle of, of sine. It goes from here all the way to there. Makes sense? Hopefully. Same thing works. We talk about amplitude. Amplitude is basically the absolute value of the thing in front of sine or cosine. So the amplitude is the absolute value. So in this case, h of t, the amplitude of this one is 1/2, and the amplitude of this one is 3. What does that mean? It means it the highest and lowest value it goes is up to 1/2, and the highest and lowest values it goes is 3. So of this guy right here, 1/2 sine t3, that guy has an amplitude of 1/2. So its amplitude is 1/2, and its period, so B is 1/3. So I have 2 pi over 1/3, and my period is 6 pi. So basically, it's going to be not, it's going to be really slow and drawn out, and it's going to be kind of squished down, right? It's going to be really slow and drawn out, and it's going to be kind of squished down. This guy's amplitude is also, this amplitude is 3, and its B is 2. So I'm going to go 2 pi over 2. So its period is pi. So it's going to do one complete cycle quickly, but it's going to be stretched up along the x-axis. And how do I know this? I don't know. I just do, but I'm going to actually graph it and show it to you. So if we look at 1/2 sine in front of this guy, so I'll go right here and I'm going to put a 1/2 in front of it, and you can see there's the 6 pi, and see how it only goes from here. The highest it goes is 1/2, and the lowest it goes is 1/2, right? It takes a long time to get there. So I'd like you to try to, you can pause the video, and I'd like you to use Desmos and take a look at -3 sine 2x and see what happens. I wonder what happens because of that negative. And I'll see you here in a second. Okay, so sometimes it helps to take a look, and it says write an equation for the cosine function with the given information. Amplitude is 3 and the period is 3 pi. So the amplitude is 3 and the period is 3 pi. So then I know I have an f of x equals a cosine bx situation. So a is 3. So, and this guy goes like that. So I'm going to say f of x equals 3 times the cosine. I don't know what b is, but the period is 3 pi. So I'm going to put 3 pi is equal to 2 pi over b. That's what I'm trying to figure out. Well, take a look. That is a cross multiply. I get 3 pi b equals 2 pi. And then I'm going to divide both sides by 3 pi. So I get b equals 2 pi over 3 pi. Pi's cancel. B is 2/3. So this is 2/3 x. That's my function. Okay, don't worry about the one over there on the right there. Now, if you look at this graph, is the tangent function. So I want to kind of look at the graph of the tangent function. So here's the graph of the tangent function. What's unique is you have asymptotes here, and you at pi over 2, you have another asymptote at 3 pi over 2, you have an asymptote at negative pi over 2, you got an asymptote at negative 3 pi over 2. That's because these are the spots on the unit circle where it was undefined. Do you remember that? That was the spots on the circle where it was undefined. So let's look at this. What is my domain? What is my domain? My domain is all real numbers, but I can't be all real numbers because it doesn't work at pi over 2. So you can write all reals, but it's all reals, but except let's say odd multiples of pi over 2. It's all reals except for odd multiples of pi over 2. So at 3 pi over 2, at the next one at 3 pi over 2, and then at 5 pi over 2, and at 7 pi over 2, all those odd multiples of pi over 2, you get vertical asymptotes. You can't have that, right? Because that's along the x. Now the range, well, this you can see this part goes up forever and goes down forever. So the range is all reals. You have anything you want as an output, right? The period. When does this thing look like it starts over? So if you go from here to here, you got this branch, and if you go from here to here, you got this branch. And then it repeats itself. So this is pi over 2 from here to here. This is pi over 2 from here to here. This whole period is pi. So that's its period. Its period is pi. And what type of function is this? Is this an odd function or is this an even function? Well, it looks like you have rotational symmetry. So I would say this is odd. Make sense? So real quick, what you can talk about here is the tangent function will complete an entire cycle from negative pi over 2 to pi over 2. And the function has a period of pi over b. So in this guy, what is this guy's period? This guy's period, well, b is 5. This guy's got a period of pi over 5. That's the period. So it's going to look like rain, and it's going to do those curves a lot faster, okay? The crazy thing about the tangent function is that it has no amplitude. My question is, why does it have no amplitude? All right. So I know this video went a little bit long, but you kind of need it. You can pause it and replay it, and I'll see you in class tomorrow, and may the force be with you.